than 10 minutes from the centre of Johannesburg lies Broadcasting Centre, an enormous complex which caters for every need. Extending over 150 hectares, the centre contains the most modern electronic equipment, and its facilities are the envy of broadcasters throughout the world.
Optical services. Hello Richard, what do we have here?
Hello Helen. Yes, this is a lens from a beta cam, one of the smaller news lenses, and a little bit different in size from this one we have here, which is a broadcast or OB type lens used on a larger format camera. Incidentally, the difference in cost, this one costs about 20,000 Rand, this one's somewhere around 100,000 Rand.
Good heavens. So, I'm very interested to know, the video camera that I have at home, how does the lens differ from, say, a camera in the studio or an outside broadcast camera?
Well, not too much difference. They say the difference between men and boys is the price of their toys. Well, as I've said, this costs in the region of 20,000 Rand. Perhaps the zoom range is a little different. They have a longer telephoto and a wide angle, as it were. And of course, unlike the home lens, which is used maybe twice a year at Christmas time and birthdays, these lenses are used every day of the year in very different circumstances, on horseback, in aircraft, underwater, in the desert, just about anywhere you care to name.
Under all conditions? Under all conditions. You mentioned the zoom range. What does that mean?
Well, the whole idea of a zoom lens, it was in fact designed for TV, so that instead of having to stop shooting and change to a longer focal length lens to do a close-up, simply by turning a ring or pressing a button, we can mechanically change the lens from a wide angle to a telephoto. And the zoom range, this is a 14 times lens, which means it can go from 9mm to 108mm. This large one we have here is very long telephoto. This is a 44 times and goes from, if I can have a look, about 12.5mm to 525mm. So it's a very wide angle and a very long telephoto lens all in one.
So could you give us an example of how far that could zoom?
Well, one of the shots I saw recently was the World Cup football from Rome, I think it was. And they had quite a spectacular shot from the stadium. They were looking out through the stadium at the moon, which was actually full frame. It actually filled the TV screen. They then zoomed back and turned around into the stadium. And the moon went from being full frame to being just a very small dot in the corner of the picture. So that gives you some idea of the range of one of these lenses.
Yes. You know, I think our viewers would be interested to know what happens when a picture goes out of focus.
Usually the cameraman's not doing his job properly, but no, but seriously, there are various things that can happen. This is a mechanical device. The tolerances are very small. We work to tolerances of 5 microns or 5 thousandths of a millimetre. As I've said, they work in very different conditions. If dust gets into the lens, it sticks to the grease and things can wear quite rapidly. So usually it's a problem of mechanical wear. Although we do get some unusual cases at New Year's Eve parties of champagne being sprayed on lenses, but that's not quite so normal.
Now, the lenses are brought to you when they malfunction. How do you go about testing them?
Well, we try to actually service the lenses on a regular basis. We have several hundred lenses in the organisation, I think between 200 and 300. And we try to service them once a year. We do. This is in fact a simple service. It's a little bit noisy and needs some grease. This lens, something different has happened. This has in fact been dropped from a gantry on the camera, and you can see the rear panel has in fact been badly damaged. The whole rear of the lens will have to be replaced, and will probably cost, I would guess, 10 to 15,000 Rand to repair.
Richard, could you show us some of the equipment?
Here we're measuring what's known as the modulation transfer function of the lens. It's a very complicated term, but what it basically comes down to is this. Instead of just looking at a lens and saying, yes, I think it is sharp, or perhaps it's not quite as sharp as it should be, we can actually get an objective measurement of the performance of the particular lens. We get a meter reading, which we can put onto a chart, and gives us, as I say, an objective measurement of how the lens is working. If we can just kill the lights. What we're doing now, we're actually sending a beam of light up through the lens, which is being measured, and we're measuring the contrast between black and white surfaces, and it's giving us a reading on this meter. This lens is reading about 85%, which is about where I would expect it to be.
Richard, this machine looks as if it's from outer space. What's it used for?
Well, we're going to be looking at a lens from a 16mm film camera, and this is actually an autocollimator, and what I want to do is just check the back focus of the lens. When I look through the lens at an image from a graticule, I adjust the knob at the back here until I get the sharpest picture, and then from the gauge we can actually read that this lens is correct within 1/1000th of a millimetre. The factory standard is in fact 15 millimetres, 15,000ths of a millimetre plus or minus, and this one is in fact well within 1 micron or 1/1000th of a millimetre.
Now that's very clear in there. What happens if the lens is damaged or scratched?
Well, the back focus can change, in which case the picture on the film might not be quite sharp enough. So what we would do, we would put shims or washers under the mount just to correct the position of the lens in relation to the film plane. We're now looking at another collimator, slightly larger than the one you saw earlier. This was actually built in this department. And this allows us to mount quite large broadcast and outside broadcast lenses. At the moment we're looking at a small portable lens. This is the power supply or dummy camera, which just simply allows us to operate the servo-operated zoom and the iris. If you'd like to have a look through the microscope at the picture the lens is showing us, you'll be able to see that it's in fact very sharp. It's in focus right throughout the zoom range.
What a fascinating aspect of video. In fact, if we weren't in focus before, we're certainly in focus now.